Hello, algebra students. Now that we've finished working with the exponents in that part of our unit, we're going to start working with radicals. Radicals are the square root signs that you see on some numbers. When we're simplifying these radicals, this is not where you just hit the square root button on your calculator. We are not going to have any decimal answers for these. Simplified radical form sometimes doesn't have any radicals in it, and sometimes we do have radicals and we have some numbers out in front. You'll see what those are going to look like. But this was the whole reason why we made factor trees. So let's take a look at these. I would suggest that when we get into the examples, you write these down so you've got some to look at. So the way that we are going to simplify radicals, there's more than one way to do this. But the way that we're going to simplify radicals is we're going to make factor trees, and then we're going to find matching pairs of factors. When we did our prime factorization, I wanted you to get those numbers all the way down to prime numbers. But right now, we don't have to have prime numbers. If we can find pairs, that's good enough. We can break them all the way down into primes, but we don't have to. When we find a pair of numbers, those two numbers together are going to work to break out of the radical. It just becomes one number on the outside of the radical sign. So let me show you how this is going to work. If I give you something like the square root of 20, and again, we say the square root of 20, but we could also say radical 20. That square root sign is called a radical sign. So we're going to just pretend that radical sign isn't even there right now. We're going to make a factor tree. So 20 could be 4 times 5. Now remember, when we did our factor trees, I circled numbers when we got to the ends of the trees, the ends of the branches. We don't need to do that right now. In fact, I'm going to encourage that you don't do that right now. The 4 is going to break down into a 2 and 2. And now these happen to all be prime numbers, but we didn't have to get primes, I said. However, this is the first place that I found a pair. These 2's, I'm going to circle them together. Those will break out of the radical. They're going to work together. They break out. Now it's just a regular 2. Not 2 of them, just 1, 2 on the outside. And the stuff that didn't get circled, this 5, stays inside. We would read that as 2 rad 5, or 2 times the square root of 5. 2 rad 5 is just faster to read it that way. This is simplified radical form. It's important that we get to simplified radical form because when we start to do things like adding and subtracting radicals, we would have to have almost like a common denominator with fractions. We have to have common radicals that we could add together. Now, if you want to check to make sure that this works, you could do the square root of 5 on your calculator and multiply it by 2. Notice what that number is. And then take the square root of 20 on your calculator. It'll be the same number. Okay? When I look at 18, again, there's more than one way to split this up. I could do 2 and 9. I could do 3 and 6. Whatever you see as the easy way to start this. The 2 is prime, so that one can't break down anymore. The 9 can be 3 times 3. And again, right there's my pair. So that pair of 3's will work together. They'll break out of that radical. And the stuff that's left over, just that 2, stays inside. Again, checking it, if you would take the square root of 2 on your calculator and multiply it by 3, or take the square root of 18, you'll get the same answer, but that's how we are simplifying these radicals. In 72, you can certainly start by dividing by 2 because it is an even number. However, if you can find bigger numbers to use to split this up, it'll go faster. 72, I would go with 8 times 9. 8 can be 2 times 4, and that 4 can be a 2 and a 2. Now they're all primes there. And there's a 3 and a 3. So I could have, it doesn't matter which pair of 2's, but I can only circle 2 2's. So I'm going to circle those 2. They're going to break out. I'll circle these 3's. They'll break out. The stuff that's left over, the only thing at the end of a branch that didn't get circled is that rad 2. It has to stay inside. And then I would multiply the 2 times 3 and get 6. Now I want to point out a different way of doing this problem in particular, the square root of 72. If you did use a 2, I would hope that it's not because of the 2. Here's the other thing that goes with 2. 36 can be multiplied by 2 to make 72. Now that 36, I could split up lots of different ways, right? I could do 2 times 18, I could do 4 times 9, I can do 3 times 12, or I could do 6 times 6, because that gets me a pair. I don't need to split it up into 2s and 3s and 2s and 3s and circle a pair of 2s and circle a pair of 3s. That's my 6. That's a pair. That would break out of the radical. And then the one that didn't break out is the rad 2. Same answer, just different ways to get there. I didn't start with the 2 because I don't want you to always look at using a 2. But if you could use something bigger like 36, that's a perfect square, that certainly saves some time. Now for 32, what I just said is look for perfect squares if you can. I could start 32 with 4 times 8, which is fine, and I'll probably do this problem again so you can see it that way. But 32 is 16 times 2. I picked 16 because I could split it up into a 4 and a 4. Now, if you wanted to, you could certainly split your 4s into 2s and into 2s, and you'd have 2 pairs of 2s that would break out. Or I could say, oh, there's a pair. I can be done. That breaks out. This is the only thing that's left. Stays inside. If you had started this problem with let's say 4 and 8. 4 is going to be 2 and a 2. This 8 could be a 4 and a 2. And honestly, if I wanted to, I could have circled this 4 from the 8 with the 4 that I had originally without splitting up that 4. But this time I chose to break it all the way down, all the way into 2s. 2 to the 5th power is actually 32, because 2 times 2 times 2 times 2 times 2 is 32. Here's a pair of 2s. They break out of the radical. Here's a pair of 2s. They break out of the radical. The one that's left stays inside. And 2 times 2 is going to be 4, rad 2. You get the same answer either way. As you work through these more, hopefully you'll start to see faster ways to do some of them, but it really doesn't matter. You can do these in any order you want to. Now, 54, thinking about numbers that multiply to be 54, I would probably do 9 times 6. 9 is going to be 3 times 3. The 6 is going to be 3 times 2. Here's a pair. Now, I know there's another 3, but it doesn't have a pair to match up with it. There isn't a pair that goes with the 2. So the 3s that I circled break out. The stuff that's left, this 3 and this 2, they just go back into the radical. And I'm not going to leave that as a 3 times 2. I'll just be back to a 6. For 125, I would do 5 times 25, right? Thinking about money, that'd be 5 quarters. And then the 25 would be a 5 times 5. Now, again, this is 5 to the 3rd power is 125. You can circle any 2 of the 5s as the ones that are going to pair up, and then there's going to be 1 left over. So it doesn't matter which ones you circle. I'll circle those 2 just because they're right next to each other. So those 5s break out. This was left over. Stays inside. And for 500, again, this one you could certainly start with a 2 because it is an even number. However, looking for perfect squares, I would use 100 times 5. And again, I could split up 100 a couple of different ways, but for me, I would do that. 10 times 10 is a pair. I know they're not prime. You can make them primes if you want to. You could get, let me write down my answer for this first. I'm going to have 10 rad 5 as my answer. If you didn't notice the 10s right away, if you did a 2 and a 5 and a 2 and a 5, I could say, oh, well, these 2s, I guess, circle up, and these 5s can circle up, and I'll have a 2 and a 5 on the outside, which gives me this 10 right here, and then the 5 is still inside the radical. To me, I would absolutely stop as soon as I saw that pair.